Hello everyone, I'm Khawla Aitarri, a PhD student at Ibn Zor University. I'm so glad to present my work at the International Network of Research and Training. My work is about an application of the analytic hierarchy process for influential nodes classification. So my plan as following. We start with introduction and we pass to explain the AHP methodology. Next is an empirical study and the last is conclusion. So, as you know, in the field of complex systems and especially in complex networks, each node has a particular role. Therefore, some nodes may affect the structure and the function of the network to greater extent than others. So, the identification of these influential nodes is essential in many fields such as network attacks, information dissemination, and epidemic spreading. So various measures called centrality measures are proposed to identify these nodes. But each measure has its limitation. For example, degree centrality, although its simplicity and low time complexity, the entire system is ignored. For betweenness and closeness centrality, they consider the whole network, but these two measures are not as impactful in large-scale network. So we pass to present the AHP methodology. AHP is analytic hierarchy process, is a multi-criteria hierarchical analysis invented by the mathematician and professor of Wharton School of Business, Thomas Sassi. It allows comparison and choice between preset options and based on the comparison of pairs of options and criteria. It's developed to optimize the allocation of resources when there are several criteria to consider. Four fundamental principles of this method are hierarchical structure, structuring of priorities, logical consistency, and semi-quantitative method. So the proposed method is composed of the following steps. Step 1, we modeling decision problem as a hierarchy. Step 2, we compute matrix of decision criteria, which means we determine the importance of each criterion to another according to the SATI scale. Step 3, we compute matrix to compare different solutions for each decision criterion. Step 4, we compute matrix of solution, and of course in steps 5 we can rank the solution based on the matrix of solution. So the proposed methodology is AHP and centrality meters. So we can aggregate centrality meters as multi-attributes in AHP. So we start with modeling the problem as a hierarchy. We calculate different centrality measures. We let centrality measures be the multi-attribute in AHP. Then we calculate the weights to each attribute. We calculate the matrix of nodes comparisons for each centrality measures. We calculate the matrix of solution scores. We calculate the global score of each node. And we classify influential nodes according to their global score. So, in light of what has been proposed over, a basic model is given to show how AHP acts in this part. So, this model is composed of 11 nodes and 16 edges. So, nodes are presented by the red color from A to K. We pass to the empirical study. So, of course, we can use the model explained with 11 nodes. So, the problem is structured as a hierarchy in AHP. A diagram is created according to the objective. So, the goal of our study is the classification of influential nodes in the top level, and in the lower level are the criteria, so degree and betweenness and closeness centrality, and the bottom level are the solutions or nodes from A to K. So in the hierarchical analysis process, the importance of criterion I compared to criterion G is determined using Sati scale uh, and is assigned to the position IG of the comparison matrix in pairs, and automatically the inverse of the assigned number is associated with the position GI. Then the following step is to construct for each centrality measure a matrix that compares each node to the others depending on each criterion. So we start with degree centrality, we compare each node with others, and of course we can base it on the values calculated yet by R software for degree centrality, and then we can determine the values using Sati scale. The same thing with the betweenness centrality and closeness centrality. So we compare each node according to one criterion. And from these matrices, which means matrix of degree centrality, betweenness centrality, and closeness centrality, from these matrices cited above, we can extract the matrix of solution, and this is the matrix of solution in the left, and by multiplying the matrix of solution with the weight of each criterion, the global score of every node is given. So after the global score, we can know that G is classified as the most influential node in the network with the IHP method. So it has an important role to connect the two parts of the network. Moreover, it's crossing important node, close to all other nodes, and it has a lot of direct contacts. So it's too adequate to be positioned first. So this is the position of G. Then we have nodes C, D, and G are the following. So C, D, and G are the following. Effectively, they are more important due to their closeness to the most central node G, and node B, F, I, H, and K are classified in the back of the network on account of their position at the periphery of the network. So for sensitivity analysis, the software expert choice 11 is used to test the variation of the weights. Performance sensitivity of nodes has been analyzed when degree centrality, betweenness centrality, and closeness centrality is increased by 15% from its current level respectively. So this is the performance sensitivity of nodes when degree centrality is increased. So we show the stability of the classification of nodes. Similarly, with the betweenness centrality, we have the same rank of nodes, and the same thing with closeness centrality. I forget the diagram of closeness centrality. So the identification of influential nodes in complex network is an important research topic. Many methods are proposed. We have shown how The original AHP behaves to identify influential nodes in a given network. We consider different centrality meters as the multi-attributes of a complex network in this application, and the empirical study demonstrates that the original AHP gives good results in terms of influential nodes identification. So there are some references used in this work, and thanks for your attention.